Hello everyone, welcome to the 6.7 B notes. This is on the fundamental theorem of calculus, just like class was, but today we are going to be talking about the fundamental theorem of calculus with graphs, tables, and symbols. But just to review before we get there, just a reminder, what is the fundamental theorem of calculus? So what the fundamental theorem of calculus says is that if f prime is a continuous function on a b, then the integral from a to b of f prime of x dx equals f of x with the bounds a to b. And essentially what that part means is that it equals f of b minus f of a. So another way to say that is f of x is an antiderivative. Because if you took the integral of that function, you get f of x. If you were to take the derivative of f of x, you would get f prime of x. And so the opposite of a derivative is an antiderivative. And we're going to do that today, but we're going to focus on tables and graphs. So we're going to skip here to example 1. It says the graph of y equals f of x is shown on the right. And then it's telling you, so this is a command. I know it doesn't say, find anything, but this implies that you need to find something. Just like if this was given to you on a test, you would need to know that the answer to this is 2x. And so this is a question. It is technically asking what is the area under the curve f prime of x from 1 to 3, but we also now can use algebraic in a mix of algebraic ways to solve that. So this essentially equals f of x from 3 to 1, which equals f of 3 minus f of 1. In this graph that we provided, it says is y equals f of x. So we don't have to do anything too crazy. We don't need to find the area under the curve or anything. We just need to find f of 3. So I'm going to go find 3. It's kind of hard to see, but if you look right here, it says 3, 0. So that means f of 3 is 0. And then I need to go find f of 1, which is right here. And f of 1 is 2. And so the answer, this is 3, 6, not 3, 0. Sorry. Okay, so 6 minus 2 is 4. And so that is the answer. That's the area under the curve f prime of x. But we don't have to actually find the area under the curve because we don't have f prime of x, but we have its antiderivative, and so that's why it works. Okay, next problem with a table. So this one says, the table below gives values of a function f and its derivative at selected values of x. If f prime is continuous on the interval -4, -1, what is the value of the integral -4 to -1 of f of x dx? So let's just start off by remembering that by the fundamental theorem of calculus, this is equivalent to f of x from -1 to 4. So the integral of f prime of x takes you back to the original function. And now we want to find this from 4 to -4, right, to -1. So that is equivalent to f of -1 minus f of -4. And looks like I don't even need this bottom part of the table. It's just kind of there to confuse you. F of -1 is -1.5. F of -4 is 0.75. And that equals -2.25. So the antiderivative of this of f prime of x from -4 to -1 is -2.25. So again, sometimes the integral is called, sometimes it'll say find the integral, sometimes it'll say find the antiderivative. They mean the same thing. Okay, a word problem. So it says, if g of x is an antiderivative for f of x, and g of 2 equals -7, then g of 4 equals blank. So this is the big idea we need to know. And if this is true, then what that means is that f of x dx, the integral of f of x dx, that means that equals g of f of its antiderivative. That essentially means that if you take the derivative of g of x, you would get f of x. So this is the antiderivative. But we're asked about g of 4, which is confusing. So we're where do we go from there, right? How do we find g of 4? Well, let's think about this. If we want to know g of 4, we know that if we were to use actual bounds, if we were to use definite integrals, if I put 4 here, then eventually I would have g of 4 if I were to actually use the whole fundamental theorem of calculus. So I'm going to put 4 there, which means I would need to put 4 over here. And then the only other x value we're given is 2. So I'm going to put a 2 here, a 2 here. And so that ends up giving us that answer. So I'm kind of just like thinking, how can I use the fundamental theorem of calculus to solve for what I have? And so I'm asked to find g of 4. Well, let's break this down a little bit. I know, so I'm just going to kind of copy this part down. I don't know what g of 4 is, right? That's what I'm trying to find. So I'm going to highlight that because that's like the piece of information I don't know, right? I don't know this, but this does tell me that g of 2 is -7. Okay, you guys also look over here. None of these are like numbers, right? So what that tells me is I'm not looking for a number, okay? So keep that in mind. So if I want to get g of 4 alone, well, first this simplifies to a +7. So I'm just going to go ahead and change that to a +7. And all I have to do over here is subtract 7 on both sides. And so I'll get 2 of 4 f of x dx, and then it'd be like -7 equals g of 4. And that's my answer. And let's see if I see any similar. So obviously this first one's out. This has an integral, but it doesn't have the -7 part. The -7 part is inside the integral. It's really important that part's not inside the integral. That's not a property that adds like -7 area, actually probably -14 area if you really think about it. So this one's out, and then this one's the closest. I know that I use f of x dx, but they use f of t, and that's the same idea. And so that is the answer to that one. Okay, last one. This is a little FRQ problem, so we're going to read through. I know that these problems are hard, but we can do it. So this says t minutes is on the x-axis. That's the independent variables, and then wt is the dependent. So it says the temperature of water in a tub at t is modeled by a strictly increasing twice differentiable function, where f of t is measured in degrees Fahrenheit and t is measured in minutes. At time t equals 0, the temperature of the water is 55 degrees Fahrenheit. The water is heated for 30 minutes beginning at time t equals 0. Values of Wt at the selected time t for the first 20 minutes are given in the table. Use the data in the table to evaluate 0 of 20 is w prime of t dt. Using correct units, interpret the meaning of 0 to 20 of w prime t of the integral in the context of the problem. Okay, lots of things here, but my main eyes go to this part right here because that's what I'm trying to find. And then I'm also going to acknowledge that this right here, while this is the integral of w prime of t, this is just w of t. And so this problem, like, you have to recognize that you have to use the fundamental theorem of calculus. And this is a problem that I see all the time, whether in multiple choice questions on the AP test or just on FRQ. But what we know based on the fundamental theorem of calculus, if we want to evaluate this, we know that this is equivalent to w of t from 20 to 0. That's what the fundamental theorem of calculus says. It says the integral of w prime of t just gets us back to our original function. And so from there, I'll get w, I can actually evaluate. So that equals this, and then I can go to my table. W of 20 is 71, w of 0 is 55, that equals 16. So that is the first part. So like example on the on the AP test, you would get one problem for getting that part correct. But there's another part of this, and it's interpret. And what interpret means, if you ever see that, is that just means explain in words, like explain in words what this means. And now, if you ever remember me saying this, the integral of a rate function, and this is a rate because it's prime, right, is the accumulation of something. And so what does this original function mean? It's the temperature of a water in a tub is strictly increasing. W of t is in degrees Fahrenheit, and t is measured in minutes. So basically, the temperature of the water is being heated. And so what is the accumulation of that? Well, that's the total amount that this tub has actually warmed. That's what the accumulation is. It has nothing to do with the rate of water like heating up. It's just the amount of degrees that it's actually accumulated. So the answer to this interpretation part is the water has warmed. It's positive, so that's why I said warmed. 16 degrees over 16 degrees Fahrenheit over the interval t equals 0 to t equals 20 minutes. So that's part A to this FRQ. Okay, let's get to the next part. So this next one says for 20 is less than or equal to T, which is less than or equal to 25, the function W that models the water temperature has its first derivative given by W prime of T equals 0.4, the square root of T cosine 0.06 T. Based on the model, what is the temperature of the water at time T equals 2? So let's just like set it up exactly how we did last time, and then we'll handle like the weird, like we actually know the equation for the, derivative function, but we'll handle that part in a second. So let's just kind of start off how we did last time and use the fundamental theorem of calculus. So we know, based on the fundamental theorem of calculus, that this right here is true. So this is what the fundamental theorem of calculus tells us. Basically, we want to find the temperature at T equals 25. So our goal is to figure this out right here. Before we do too much work or anything, right, we don't have the original equation, right? We only have the derivative equation. So we're kind of getting stuck here with finding the temperature of the water from the original. But we do know that at 20, based on the table, we know that it's 71. And so at this point, we do know here, you know, this. We still don't know what W of 25 is, but we do know that this equals minus 71. Okay, so we'll start there. Now let's go ahead and deal with the other pieces of information we know. Okay, we're gonna go here. Actually, before I go on, well, you can write that down if you want to. I'm gonna go ahead and add 71 on both sides because I'm gonna put the 71 out in front this time. Doesn't really matter, but I'm recognizing that this is the expression that will give you W of 25, this right here. Now, one other thing we know is, remember, we actually do know the equation this time. We know that the equation is 0.4 square root of T cosine of 0.06 T dt. We know that that equals W of 25. Now, we don't actually have to do that much more work. All we have to do is put this expression in the calculator. And so I'm going to go get my calculator. Calculate 84. You can use your calculator you have. And this should be a review. I'm going to go to math. And then I'm going to scroll down until it says integral. I'm going to press 20 to 25. This is such a popular question on the AP test. I see it all the time when we're reviewing for it. Typing in this function, I have to use x's instead of t's. Cosine 0.06 x. Then I press equals, and I get 2.043. I'm going to do 2. So I'll have 71. Plus, the calculator told us that this expression right here equals 2.043, and that's going to equal W of 2, or W of 25. Add that together, I get 73.043, and that is the temperature of the water in degrees Fahrenheit at 25. And so that's how you do a problem like this. So use the calculator, always rely on that. Not as bad as you might think it is. That is it.